Hi, today I'm going to show you how to calculate percentage impervious from land use and land cover dataset. Here we can see we have land use and land cover dataset for the year of 2006, and this dataset is from probably Sentinel 1, since we see the name here Conus A1B. If it is Sentinel 2, then we can see it will be like A2B. So whatever dataset you have, you can use the global dataset. I have videos on that as well. You can see that how to download this dataset. But once you have this data, so how to process this dataset and how can you calculate the percentage impervious for your study area. So let me show you the study area we have. So that is the study area, and here it is. It is locating just close to the city of Houston. Here it is. Okay, city of Houston, here close to the Houston city. And how many subwatershed we have. If you want to even set up any model that needs, for example, HKSMS model that needs percentage impervious, okay, so you need to even calculate that value. So how many subwatershed we have here of FID from 0 to 130, so it's like 131. We have 131 subwatershed here. So my idea is to calculate, because if I turn on that field, see, it is even covering this, okay, and it has different land use and land cover information. So based on that land use and land cover information, today I'll show you how to calculate percentage imperviousness per subwatershed. That's what we need. The job is pretty tricky and laborious, and it will take a different sequential process. So I'll show you that step by step, and I'll show you an automatic process if you have many subwatersheds and if you have data for different time periods. So you have to do the same thing over and over. So instead of doing that, if you make it automatic, then you can run the script and automatically you will get the results as Excel file, right? So the output will be like this. I already tried that and I have that data set. Let me show you the output of this. So here is this. So you'll get the output as Excel file. And here it will give you everything, percentage imperviousness, okay, it will give you this everything. And if you want even every other data per class, even you will get this, not a problem. And it will give you the data set based on your sub-basin name. So that's pretty convenient and pretty useful for any research. So let me show you that. So first I'll give you the manual demonstration. The first step for calculating this percentage impervious is to crop this data set for, right, based on our study area. And because we don't want to even use our entire data set, because we don't need that. It will even kill our space, right? And memory as well. It will take a lot of time to process. And sometimes if you deal with big data sets, so your computer may not support that. So the first step is to even crop it. So how can you do that? When I'll make all these processes from now on, I'm going to show you at the from beginning to the end. I'll make it like automatic in the second part of this video. So here at first, my idea is to crop it. How can I crop? So I can use the extraction tool, and I have already generated a tool for calculating that, and that is the automatic process I'll show you in the second part. So you can go to spatial analysis tool, and then you can go to extraction and then extract by mask, okay? So if you just open that, it is gonna ask you for a raster. So which one? This Conus A1B, that is covering the entire conterminous USA. So from this dataset, based on our study area, we'll extract or crop it or clip it, okay? So now we are gonna even give this name, okay, for study area. So the output will be extract T5. Let's see, I'm not gonna change anything. So quickly it started, and since I already turn that on the background processing, so that's why it's running in the background, and we can see the results within shortest possible time. It depends on your computer processor speed and other. See, I can hear the sound. Yeah, maybe it's done already. It is gonna show you this. See, so here it is. I'm turning off the previous data set and we have this. See, it's already cropped. So this is my study area and it is giving you the raster data set. If I turn this off, we can see this is the raster, and let me show you the cell size. This data set is not that very high resolution. So if I right click on this and go to properties, and then you'll see the cell size. It is 250 meter by 250 meter, right? So that is the cell we have, and this coordinate system is Olbers conical equal area. Okay, so keep in mind that we have 250 meter by 250 meter resolution data set. We'll use that. This is only for the purpose of demonstration. If you have 10 meter resolution or more than that, that will be even more accurate for the calculation. So now see, we don't know what does it mean by 1, what does it mean by 2 and 3 and 4 and 6. So you have to know, right, the cell value. If the cell value is 1, for example, here, see the purple color, this should be water, right? So I'm gonna change it. I know that. I'll show you the description because I already have that. So when you download this data set from their website, you'll even get all this description. So this is the water bodies. And what is 2? So I already have the description here in another table. I already made it. So when the cell value is 1, it is water. When the cell value is 2, it is developed. And when it is 3, I don't know, but I have the explanation or the description from 4. It's mechanically distributed other public lands, and for 5, it's mechanically distributed private sector, and then for 6, mining, 7, Baren. So this is how we have up to woody wetland for 16. So the computer, right? Computer knows that, okay, this 1 means water, 2 means this, but as a human being, we need to know this description. Otherwise, how can we even differentiate, right? So since this data set is human readable, this description, we'll use this description to calculate, to find out this developed land, and based on that developed land, we'll assume that, okay, the percentage imperviousness will come from this developed land, because if it is concrete floor, there won't be any water infiltrating through this surface, so that will be like impervious surface. So we'll calculate the percentage of that developed land per sub-watershed. That is pretty even a little bit difficult. So next job, we already have this boundary, we have our study area. Now what I have to do, I have to connect this description, because these values are similar, and this description with this description. You can see we don't have 3 even here. That's why I made this table, right, in a way so that we can even make it identical, and we can even connect based on our value. So my next job is to connect this table. If I right click and open the attribute table of the raster, we can see we have the same values and we have the number of counts. So from this count, if you know the cell size, you can add another like field, and you can even multiply 275 into 250 into 250. You'll get that water area for your entire study area. But we don't need that. We need the percentage of area per subwatershed. But from this total number of count, we can't get that. So that's why we need some other processing, right? So this is for the entire study area. So we don't need that. So first, I need to even connect the table of this roster with this land use class. So how can I do that? I can use another tool that is called join, right? We can join the table, this table with that table based on that common value. Okay, so this is here we can even join. To add join, I can use this command add join, and I'll do this thing automatically in my next part. You'll see, because this is really difficult job, you can't even remember what you need as a sequential step. So here, layer name or table or view. So here I'm gonna use that table of extract T5, this one, and input join field, this will be the value, right, from 1 to that. And here join table, we have the description there, and here you can see we have the same value. Okay, so what it is showing, this the join field value table is not indexed. Why? Not a problem, means yeah, definitely it will work. Why it is not indexed? Let me open it. Yeah, the value is showing 1 and 2 and everything is okay, not a problem. It will definitely add. Okay, let's try. It should work. Add join. Okay, let's try and let's see if it works. Definitely it will work. Maybe it is just giving us the warning because it is a raster, so dealing with the raster dataset sometimes difficult. Maybe it's done. Let's see if we are done. Then definitely we are. So yeah, see, we can see that, right? We have this type, and then we have everything there. Okay, so that's great. And even you can do it in another way as well. So there is another way. If you even don't want to, even add all this thing, if you just want to add only this type, we can even do that. Okay, we can do that. So now I'm just removing every joins and everything because I have the join. I'm removing everything. So what I can do, I can use join table or add table. Okay, add table. So let's see, add field and join. Okay, join tables, join table. Here if I use join field, see, if instead of adding this one, add joint, if I use join field, so let's see, now we have different data set, right? Different format. So here I'm going to add this extract, and what will be the input field? This one, value. This time it is not showing any error. And join table, this will be this land use class where I have the description, right, based on this. And here I'm going to use the same output join field. It will be based on that value. So it will, when it will match the value from that raster with this value from this table. So what I want to join, I can keep all this field, but I don't want that. That's why I change it. I just showed you the other way. So I need only the type, means the description, because I already have here everything, right? I have the cell value, everything. So I need only those. Okay. So if I click, then it is gonna just add that type here. Let's see. When it's done, hopefully we are gonna see the result pretty quickly. That's why we need to even extract our raster based on our study area. So you can see we already added this one, the table only, other than adding the entire field from those description, right? So we are done with this one. So what next? So now I need to even calculate the area per subwatershed based on this water developed and this class. Okay, so how can I do that? I can use a tool that is called, if you go to your spatial analyst tool, and then you can go to journal and you can use that tabulate area. If you use tabulate area, and we are gonna use because see here we don't know the subbasin name, right? We have the subbasin name there, right, inside our shapefile. So we are going to use our shapefile, and then the field subbasin. You can see if I open the attribute table, this subbasin, right, this one. So the journal field is subbasin, and input raster, the raster here T5, that is the raster where I have the description. And here what will be the classified field? Means this time I need the type. I need to I can even calculate based on the value, that's okay. But then I have to remember, okay, 1 for water, 2 for developed, 3 for this, and then 16 for woody wetland. I don't want that, right? I want only the description. Based on the description I can easily identify it. Otherwise every time you look at the table and the number, you don't remember everything, right? You can't remember. So you have to go back to this table. So instead of going back to this table, we already added, so it will give you the description and the area based on those classification and the calculation, the table will be even per sub basin. And let's see if I hit, and here it is gonna give you table. Okay, tabulate shape 1. Okay, no problem. So I'm just keeping it as it is just to demonstrate, and it's gonna calculate, and the output will be a table. And when we'll have the table, then it's pretty easy. Okay, we already have the table, and let's see what we got. And here you can see we have the sub basin and we have water. So for this sub basin, the area of water is 0. For developed, it's 0. For this one, it's 0. But here, private, we have this area, and this area is in square meter, because we know the cell size is 250 meter by 250 meter, right? So we have up to this, based on this classification, land use and land cover classification, now we have this data as a tabular format, right? So now easily we can even calculate the percentage impervious, right? So if you sum this data set, means all these columns, right? For this row, first row is for this sub-basin, and if I just add all this, so it will give you the total area, right? And then if you divide this 0 divided by the total area, then it will give you the percentage impervious. If you assume that, okay, your developed area is only impervious area, and if you have other, you can even add those two as numerator and divide it by the total area as a denominator, then make it percentage multiplied by 100. Okay, so we can see doing the same thing. It is laborious. That's what I'll do. I'll make it automatic process. So for calculating our percentage impervious, I can add one field. Okay, one field. So this field will be like total area. I need the total area. So total area, and I'm gonna give is as a double. Okay, so total area field is there. So what I have to do, I have to calculate the total area, then I'm gonna add another field. So here that will be impervious. Okay, this is basically percentage impervious, but I'm giving the name as impervious. Let's see, it's percentage impervious, so I'm gonna give it as a short integer. Okay, short integer, because it is up to 100. Okay, or long integer, whatever it is, you can give the name, no problem. Okay, but I'm gonna keep it as integer. Okay, so that's it. Okay, cancel that short integer. Maybe the name is not valid. Okay, that's why I didn't want to give that percentage sign, short integer. Okay, we have this fields here, right? We have total field. So now I'm gonna calculate the total area. I'm gonna make the sum of these columns. So what I have to do, field calculator, right? And then total area will be equal to the summation of what? Water plus developed plus this plus this plus this plus barren, okay, plus deciduous plus this plus mixed forest plus grassland plus shrubland plus cropland plus pasture herbaceous, okay, plus woodland. So if everything is okay, then it is gonna give us the total area. Okay, let's see, we got it. Okay, now since you know the total area, now here we can calculate the percentage impervious, right? So we are considering developed this column as impervious surface, and we are gonna divide this value, and then we'll get it. So let's calculate field calculator, and then remove that and put developed multiplied by 100 and divided by the total area. Okay, this total area, then it will give you that. See, we have this as integer. Okay, so now we have that based on our sub-basin, okay, percentage impervious. So we're done. But the problem is, if you have the same data set for multiple years, and if you have this study area not for this one, if you have for another location, and if you have another location, and if you then you have to repeat all this process, right? You have to add table every time, you have to join table, you have to transfer this description from this table to the raster table, you have to like extract this, you have to mask it, then you have to do all this calculation, and then you are not done yet, right? So you are done with this table. You have this table. Now from this table, you have to convert it to Excel. You have to export it. So how can I do that? So these are the process I'm gonna give you. So conversion Excel, so from table to Excel. So this is the last step. So we have that table and we are gonna save it there. Can you remember that? Here is grass. Okay, so I can remember that. So it's working, you can see the message, and shortly it will be done, it will save. Okay, so we have the output. Let's see what we have there inside our project. So it should be here, or it's grass, it should be there, or maybe it should be inside this GIS files. Yeah, there. Okay, so here we have this, check the date, the time, this one. Okay, we have this table at shift 1. Okay, so that is the output we have here. You can see we have this sub basin name, we have water developed, and you can even calculate the percentage for like barren land, even for forestry, everything, and we have this percentage impervious. Okay, see the maximum is 100, and it is basically based on your data set. If your data set is more high resolution and more accurate, then it will be more accurate. So that is the process, and that is the first part of our tutorial. But in the second part, what I'll do, I'll make it as automatic process, and I already have several data set. This data set for the conterminous USA, and what I'll do, I'll make it automatic so that it will do all its thing, all the processes I have done, and it will give you that Excel file, right? And it will calculate the percentage impervious based on the sub-watershed, whatever sub-watershed or number you have, or wherever it is, it doesn't matter. It will automatically give you the output. Okay, so until then, it's done, and I'll start the next one and I'll give you that. So if you have any query or difficulty doing the same thing, let me know. Okay, so thanks for watching. Thank you very much.